Okay. Then it will be hard job to keep it here. All right. Okay, so thank you very much for coming.
One second.
Yeah.
If you're a person who didn't sign the photo release, you might have to sit back there to not be in the photo. Yes. I don't know if there was anyone else. All right.
All right. Yeah. Thank you. Okay. Yeah. I would like to start with the name of one person who is here, Will Court.
Oh.
He's the author of Get Programming with Haskell book, and I was happy to get it at the very early stage as a reviewer. I think it was like 2 years ago,
at least,
maybe even earlier. And it's the first beginner's level book on practical Haskell. Haskell that can be used in production, and you can see things like data text type there in the very beginning, and there are words like, well, it's not a good idea to use strings, use data.text there. You can read about Unicode, you can read about a lot of stuff. Of course, you can read about monads and stuff like that. So it's a really very good book, and I should say that after we have this Will's book, Get Programming with Haskell, we were ready to get another book, like intermediate level book on Haskell, on practical Haskell. Because, of course, we had real world Haskell, and it's 10 years old. And now I'm writing the next one, which is Haskell in depth, and hopefully it will be ready in a year or so. And this talk actually is my preparation for writing one of the chapters of that book, a chapter on error handling, and there is a section on logging there. So my goal was to get the picture of a logging ecosystem in Haskell. So how they do that in Haskell. So I'm not going to give you a tutorial on some Haskell libraries. I want to show you different levels of those logging libraries. I want to present you some ideas which are important for this particular task. So it's not a tutorial, it's not a big overview, so I will not list all logging libraries. I will just give you several examples which I personally consider important for this logging task. All right, so of course, if you are writing serious application in Haskell or in any other programming language, you need logging. So let's start with the definition. Maybe it's the wrong one. So when we're talking about logging, it's actually recording anything. So you may want to record errors. So if something is unexpected you have in your program, then you can record it to analyze it later. Sometimes you want to record events, and those events can be events in your domain, like if you are writing a program about prices, stock prices, something like that, then you want to record every change of that price. So sometimes it's events in your application when you want to do something, when you want to remember what exactly you are doing at this point of the program and at that point of the program. And you may also write history, so to record everything which is going on somewhere in this program, to analyze it later, to get whether it is a performant program, are there any security problems or anything. So you just can write the whole history of the program. So these are different scenarios that you can use for when you are doing logging. And of course, this logging can be very boring, but the good thing about logging is that it features several very important properties. So the first property that I'd like to talk about is the decomposability. So this task can be clearly decomposed into several components. it's a source, so it's some instructions in your code which actually do the logging. It's also an object, it's something that you log, that you write down, that you record. It can be anything. I think in most programming languages it's just strings, or maybe text type, or something like that. But it can also be data types, and if it's data type, the object that you log, then we usually say that it's structured logging. So you log structures and not just plain strings. It can be JSON, JavaScript object notation. So technically it can be anything. So you can use logging for that. And then there is also a sinks, or destination for your log. In the simplest case, it's just a standard output or standard error. But sometimes it's a database, so you can record your events in the database, or you can use any stream processing service, like Elasticsearch, which is quite popular nowadays for acquiring logs from programs and then for analyzing them, or you can use your own standalone Kafka service. It's another stream processing application. So you just use anything, whatever you want for recording actual information from your application. And then another property is that this logging process is also can be clearly divided into stages. So you should first configure your formats, so how you want to log this information. You configure your sinks, so where you want to put all that information. Then you acquire all resources, as usual, like open files or establish connections, something like that. Then you write logs, well, just whole runtime from the very beginning to the end, and then you release resources as usual. So you see these structures. So it's not just something arbitrary. So we have structure in components, we have structure in stages, and this is a good thing for Haskell. Haskell is very good for structuring things, for assigning right type for the right idea. So if we have Haskell, we can describe all this situation very clearly using different Haskell features. So, and that's what they do in Haskell logging libraries, actually. So they try to use sometimes very boring features, sometimes very high level, very abstract features to describe this clear, simple process of logging. And then there is another point. If you ever heard about aspect-oriented programming, for those guys in aspect-oriented programming community, logging is a very important example of so-called cross-cutting concern. So if you see here in this picture, you can see two files with source code. And then these green parts here, green bars, they are logging instructions. So in every file of your application, you have something which belongs to logging and something which doesn't belong to it, something external. So you may do all other stuff in your program, but then there are lines almost in every action, in every function, which actually do logging. So this is actually cross-cutting concern because you have many small pieces of code which relate to logging. And in that aspect-oriented systems, they try to solve tasks like this. So they can remove these pieces which do logging, or they can put them back. And all these pieces together, they're called aspects. So it's just one aspect. Logging is just one aspect. And then they can modify those aspects somehow. And logging is an example which they use all the time. So this idea, it is also special. So we can try to think how we can use the same ideas in Haskell. So to switch logging completely, or to add logging, or to modify logging. So for example, we have some action which does logging in some way, and then we want to change the destination for that log or something else, and we can do that in Haskell too. But we don't need this additional concept of aspect, because in Haskell we have enough type system features to describe what is actually going on. All right, so this was an introduction, and I was trying to count every logging library on Hackage, and I found about 30. And I don't think that, I think actually that there are more than that, because the last logging library I found this morning, the problem is that they're not clearly marked as logging library. They don't have logging in the description sometimes, but they are logging libraries. They have categories on Hackage, and there are logging libraries, very popular, which are not in that category. So I think maybe they can have 50 libraries or something. So why programmers write libraries for logging? Well, because it's an interesting task. So it's not very boring. We don't have too many logging libraries for other mature programming languages, but we have them in Haskell here. Of course, I will not talk about all of them. So I will just try to give you 3 levels or 3 worlds of those libraries. I will try to describe how they differ from each other. So just classes of logging libraries in Haskell. So the world number 1, it's extremely boring logging. So if you think about other programming languages, you may have your own ideas. For someone, it can be Java logging, very boring. For someone, it's Python. So I've chosen one library, which is called HSLogger, which was patterned after Python's logging module. So in Python, it is used very well. So in Haskell, we'll see that there are some problems, but let's see some statistics here. So this library is called Versatile Logging Framework, and it's quite old actually. So it's more than 14 years old. And it's actively maintained. So you see that the current release is September 24, so this year. It's quite fresh. And it is used very well. So of course this is Hackage statistics, and it does not give you exact numbers actually. But you can compare these numbers for other libraries, and you'll see that this is quite popular even now. So if for a month more than 200 people use that, then that's a quite popular library. Now let's look at it. Let's look at a simple example. So first we should we should write logs in the IO monad. So if you see code like this, from these 3 lines of Haskell code, you should immediately come up with a lot of problems in this code. So right now, we have no information about the destination of these logs. So we see that, well, we want to write debug information with some name of the component inside our application. This is our message. And then this is a warning. But where are they going on? So what's the destination? So we have to know, well, this library use by default standard error. And another default is that debug information is not written into standard error. So we won't see the first message, but we'll see the second message in standard error. And that's not a very good thing actually. So these default things and the standard error which is used by default, and then this is debug is logged, warning, debug is not logged, and warning is logged. So it's something that we should know, but we can't see that from the code, and that's a problem.
Excuse me, does debug go anywhere, or it's thrown out?
Just thrown away. And
why would you need it?
well, because you can enable logging debug information. So of course this is useless because we are in the beginning of our program, so we will never see that. Yeah, but by the way, thank you for this question, and if you have a question, please ask immediately. Please stop me any moment, whenever you want. The next part of this code, this main action, it's writing log into syslog facility. Like in Unix, they have this syslog, so we can open log. And well, I think I will not try to explain every word in this code, but we'll definitely use process identifier. We will put some information about the user, and then this debug here means log everything which is debug or more severe. So including warning, errors, and everything else. So we've opened this log, and then we do something which is just look very awful for Haskell. So now we see that there is some global logger, and we update it. So we just mutate state there, and this global logger is named root login, and then we just add this handler. So we had standard error, and now we have this syslog, and now all our information from logs will go into standard error and into syslog. So for example, this error will be recorded twice. One is syslog, another is standard error. Okay, next part of this code is now we want to ask our global logger, this is the god of this logging system here in this application, we want to ask it to set level for debug. So now we don't want to throw away anything. So we want to log everything, including debug messages. All right, so we have updated it, and now all these messages will go to both logs, to standard error and to the syslog. Do you like this code? For me, it looks like a Fortran, something close. But that's not the end. So we could change output format. So we could say ask HS logger to format it nicely. And how we do that? Well, so here we're using another handler for logging into file. All right, starting logging everything with debug and hire. And then here there is a lambda function for describing formatter. So logger is responsible for formatting too. And here you see this is well, it's not Fortran, it's something like Perl or PHP with string interpolation. So it was built into HS logger, so it analyzes it's like $time means you have to put time in here in this place. And it's just a string so in Haskell it's a string, but then HS logger transformed it, interpreted as a special DSL for describing formats. All right, so now we created this handler with this formatter, and then we update global logger again with another handler, and now we can debug everything into 3 handlers using this format, and this will be a result of this command. So this is an example of how it was formatted here. All right, so I don't like this code. It's not a bad code, actually, but it's not very Haskellish. So it's not the way how we usually program in Haskell. And here I tried to give several reasons. So, of course, we should write all that stuff in IO monad, and sometimes we don't want. We may want to have some monad transformers tags or some more elaborated structure for our application. Then we have this global state with global logger, and then we're using strings for everything. And of course, it's not a good idea. But remember that this library goes to 2004, so it's quite old. I think there were no text type at that time.
I don't think byte string even existed back then.
Yeah. So All right, but still, we nowadays, we don't want to do things like that. So we don't want to use formatting strings with this string interpolation without any type checking, without any control. And this configuration, so whenever you want to add a logger, you have to do everything in imperative way. So you open the file, and then you set formatting rules, and then you add this handler. So it's not very declarative. So it's not what we are usually doing in Haskell. So some would say that it's just ugly code, but I don't want to say that because, well, people use that library. Maybe they like it. All right. Let's look at the core of this library, and we'll see why it works like that. So this is so-called log handler. So it's the main type class, which is responsible for everything. So you see that this type class here, it is defined for any type A, and this type A should have some logging level information. It is responsible for formatting. So you see that if you can set formatter, you can get currently installed formatter. Another thing which is not very nicely looking for Haskell is these two functions with the same type. So it's actually emitting means actually write log, and handling means emitting with formatting and level. So and it has default definition actually. And then of course there is a clause to close all resources which were required during logging. And when you have this this type class for logging, there is also this existential. So we had existentials at that time in Haskell. So this is basically means that we will be able to put all handlers which are different, which have different types. We can put them into a list. So we can use many different sorts of loggers, like one for standard error, standard output, syslog, and anything else. So that's why we use this. So now we'll put all this stuff here in the list. All right. So this is log handler. So the type class which describes everything which somehow relates to logging. Yeah. Question.
Is the priority hard-coded setting in the...
Yes, it's just, priority is hard-coded. There are just several, it's simple algebraic data types. It's like debug, error, several levels like this. So you cannot come up with your own levels. So everything is fixed here. All right. And this is logger. So what is logger? Logger has some information about level. So whether to filter these messages or not. So if it's nothing, then it is not filtered. If it's just debug, then debug and higher. If it's error, then log only errors, something like that. And then here you see this list of loggers, list of handlers. And here we're using that existential type. So if you have a logger, then you can add several handlers, and then you can also go over this list and emit your message into every handler. So that's why we use this list here. And then there is a name for this logger. And then you may have a lot of loggers in your program, and they are structured into log tree. It's actually a map, and this string here, it is hierarchy. There is a hierarchy of those loggers. Because, remember, we have these names, and you can use periods in those names, and then you can set some properties for logger, which is parent logger for another one. So there is whole infrastructure for tuning that stuff there. Actually, there are many other logging libraries like that. So here are just several names, and you may see this many authors, they have great ideas on how to name their logging libraries. So it's a pattern that is used many times in Haskell. So when you want to do something which was done before 10 times, it's quite difficult to come up with a new good name. This fast logger is actually very good. It's very simplistic library, but it is good for scaling in multi-core environments. And here you can see another idea. So if we have this simple logger, in Haskell usually we are able to create some wrapper. So we can put this log into some other library which is much more sophisticated, which can do a lot of things, and then it will use this simple logger on the hood. So this is what they usually do in Haskell. So this library was new to me. I never heard about it, but it's like 7 or 8 years old, simple log, and it's actually simple, and then you can use it in many applications. It's not bad to be simple. So this is what I want to say. These libraries, they are not bad, but we can name them. We can say that they are low level, and that means that we can use them if we don't need high level stuff. If we write a simple program, then it's okay to come up with any of these libraries. So if you like it, you can take it and you can use it. And there are quite a few users for every library like that. But we should go further, because we have another world here. So these libraries, they're boring too. But the good thing is that they are practical. In this section, I will talk about 2 libraries. And maybe I'd like to ask you, do you have any ideas which 2 libraries you could name moderately boring but extremely practical, if you know any?
Tasty quick check.
No, it's a tasty quick. It's testing libraries. And it's testing, and we're talking about logging.
Monad logger.
Monad logger, exactly. So it's Michael Neumann's library, and I think it's the most widely used logging library. Okay, I will start with it, and then I will show another one which I've chosen for this presentation. So this is Monad logger. I think that this number is the biggest with another logging libraries. So it's and we know Michael Neumann as a big professional, like a king of industrial Haskell. Actually, I think he maintains a lot of libraries for Haskell ecosystem. So he's very well known in Haskell community. So it's also quite old, 6 years old, and it is very actively maintained. There are many downloads, and so let's see what we have in that library. And in fact, this library uses fast logger on the hood, so it's an example of a logging library which is high level and which use something low level inside it. Michael Neumann is well known for using plenty of small type classes. Every library which he wrote has at least a dozen type classes, and almost all of them are one or two methods. So this is a type class for logging, and just compare it with a type class with 8 methods in HSLogger. So what is logging? Well, it's just this simple function. So let's look at it. So we have some type for messages, and even from this name, you may see that message is something which can be converted to strings. Okay? So we have location as an argument. So it's the line of code where we generate that log information. It's a log source, so applications component. It's a log level. And then this message, And then, this is the most crucial part here, we can do that for any monad. So we are not fixing I, we're not locked in I here, we can use whatever we like. And if we have this type class, then we can build another one. Sorry, looks like, yeah. So this type class is the type class for logging when you have IO in your monad stack. So if you have IO as a base monad. And then we can just ask for logger. And again, what is a logger here? Logger is actually a function with the same arguments. So in this IO monad, you can just ask for the logger, and then you can use it. So if you are somewhere in your monad transformer stack, you just ask for the logger, and then you log whatever you want. So that's an idea. And we'll see this idea even much better crystallized later. So when I say crystallized, I mean, so logging is a function actually. Here we see that it's quite sophisticated function with a lot of arguments, with allocation, with level, but it's just a function. So if you've got this function, you can log something. So that's the simplest idea of logging. And then you have several transformers. So if you have monad stack, you can add this layer of logging, and they're quite simple. So the transformer for logging is just this function again. So you have a runner, and you supply this logging function, and then you're ready to do whatever you want in any monad. So that's it. So just run, this is a function, and when you're inside this transformer stack, you use this function, and that's it. Then you also have several standard simplified loggers for standard output for errors, like this. So you have some computation in this transformer stack, and then you transform it into your monad. So as usual, you just remove one layer of monad stack, and then you get something inside. And with all logging done as expected. There is also this new type for no logging T. And this is something which should remind you that aspect, the ability of aspect to be completely removed. So if you change this, your stack, if you go from logging T transformer to no logging T, then there will be no logging in your code. Of course, the code for logging will be still there, but it will not work thanks to this transformer. So that's the idea of switching it off completely. So it's still there, but it will not be executed. So we don't need all that stuff with aspect-oriented programming. We just provide this just change one layer of monad stack here. You can also do filtering, and if you think about it, it's just something. You have some computation with all your log emitting instructions, and you can filter out whatever you want. Like, I want only errors, or I want only debug information. You can do that with this. And you can change completely monad and the result. This is something which is rarely seen in programs. You can change monad, you can change result type. So usually you can change only result type. Yeah, if you have just one monad with all those binds and everything else. But here, if you can go from one monad to another, then you can actually change, keep your logging and change transformer stack completely. And in fact, we don't have to use IO. In the same library, we have this write logging T transformer for writing logs into a difference lists. So different lists is just efficient way for keeping lists in the memory. So we want to be performant, and we don't want to use too much memory. So that's why we use these difference lists here. It's some special data structure which reminds lists but looks a little bit different. And if it's a writer, then it's just a write as writer monad. So we don't have to do any IO. So we need another runners for this monad transformer, which should give us logs as a list, as a difference list. And these runners are just as usual writer monad. We have run writer, which gives us a list of those lines, and exec writer, which gives us just list of lines without any actual result, as usually. So quite flexible library. We can use IOS text, monads text, or we can use writers text. So just pure computation without any IO, but we can still do logging there. All right, but then there is one piece left here. So how we write logs. And this is where all current libraries are actually very good. So they want to simplify the process of logging, because when you are doing configuring, you're doing it just once. And it may be very difficult to configure something, but you don't want to have your logging functions difficult. So you want them to be as simple as possible, because you write them everywhere. So this is what we have in this library. So we start with this function, and we always have it. It's a function from a type class, monad logger. And we have to provide all this information. And of course, we don't want to provide that. So we don't want to specify every line number for location. Maybe we don't want to specify level every time. Well, we have to specify message in the end. So this is basic function. And then all other functions are using it, but they make things simpler. For example, there is a set of these functions for logging, and it's for logging error. And you see that level is hard-coded into the name of the function, which is, well, maybe not very Haskellish either. But it's easier to write things without any spaces, just name of the function, that's it. So the simplest version is log error n, and you just provide your message, and you don't need anything else. And S means source and the message. And source, when I say source here, it's a component, like main.component number 1. So that's the source. And then there is this CS version of this function, which is using call stacks. There is a special module in that library which allows you to provide exact location in the stack. So as usually you will see some information. Well, this log was called in this function, which was itself called in that function, which was called in that function. Just as in Java, we have all those stacks in logs sometimes. So it's the same here. And then we have also another functions for debug information, for warning information, for just information. So they all use the same pattern for names. But what do you think? Is it possible, if you have a function like this, is it possible to provide line information here? So if you write a function, if you call a function in Haskell, is it possible to find out which line number is it in? Well, it's not possible. And for that, we have template Haskell. And this is another thing which is used all the time in almost every logging library right now. Template Haskell is able to do that. So when we write something like that, template Haskell generates code of logging function exactly in this place. And template Haskell knows precise line number. So if you use something like this, then it's just the simplest way to do that. Of course, if you use template Haskell, then it's some, maybe you may have some performance considerations in mind, so there can be some problems, but it is very convenient. So, and they use the same letters here, the same postfixes like S with a source, and several others. And of course, there is log debug, log warn, and many others. So that's an idea. And this approach to logging functions, it's actually, I think it's a standard de facto. So any other good libraries use it. So just you can see it everywhere. Template Haskell for providing precise location in the code. And here is a trivial example. It's a monad stack with a state inside it, with IO monad as the base monad, and with logging T. And here you can say just operate with the state explicitly by lifting. Of course, it's a second level, starting with the logging T. So it's get, I'm doing with lift, and put is done with lift, and then I'm doing just logging here. Log, and then some information. So here I'm working with that. If you remember that message, it was there was a constraint to log string. So here I'm working with text type actually, because text implemented and it's very easy. So I just pack this string into text and then using usual semigroup operation combine everything. So that will be my log string. And then I'm working with another layers of monad stack, then debugging something, then returning, and as a result we could get something like this here. So it's a pretty decent log information, and we have this information about exact code location. So this is what we usually expect from the logging library. Of course, we can get a lot of other stuff like times, like what we don't have here, or whatever. It's very has very rich system for configuring actually. Okay. So this is monad logger library, and it is really very practical. So it is used very often, and it is very good for MTL style applications like monad transformer library style, where you have monad stacks, where you have type classes for describing functionality of every monad, and then you just write code using that functionality. So that's an easy thing to use to do logging there. And even if you are writing just simple application with IO without any other monads, it is also possible to use that. If you remember that there was a type class for monad logger IO, then you just ask for logging function, and then you can do whatever you want in your very simple application. Okay, and now second library. I've chosen a library which is named, where is it? Which is named Katip. Does anybody ever heard about this library? Okay, great. Well, it is quite popular. So 5,000 in total, and given that it's 3 years old, well, it's not extremely popular, but well, some people use it. And the good thing about this library is that it supports the biggest number of backends. So if you want to log your information into something which is less trivial than input-output, then it looks like you have to use this library. I think that in many companies which use Haskell professionally, they actually, they may not use this library, but they have their own libraries with their own backends which are not published on Hackage. So I think all of them doing something non-trivial with logging, but this library is published, we can all use it. So every other library is just hidden somewhere in industry, so we're not able to use it simply. All right, so this, let's talk about it. And yeah, I'm writing here that logging in that library is a bit tedious. In fact, it's not a bit tedious. It is extremely tedious. And that's something that you always see in Java. So if you have experience with Java, then you know that you have to provide a lot of information. So you have to write a lot of code to get it running. Because, well, it's a difficult thing. So if you're writing some enterprise application, you have to think about lots of stuff. So this is what they do here in this library. So let's start with a well, it's simple example. It's the simplest example of using this library. So we're creating so-called scribe. Scribe is another word for backend. So scribe is something which acquires our log information. So file, any file can be a scribe. Some cloud service can be a scribe. So everything like that is a scribe. So here we're creating scribe from handle, meaning that we're working with files, and we're using handle standard output. It's just a name from system.io. So it's pretty simple thing. So we want to write our log here to std out. And I think it's pretty explanatory. So it will try to do coloring there. So our logs will look nice. This is verbosity level here, v2, and this means that we will log everything, starting with informational records. Okay, then this is the hot stuff here. So this is an action for initializing logging system. So there is an action for initializing logging environment, and you just see this. So this is component for working in production, and we can use testing, we can use development. So it's real industry here. It feels like industry. And when you have initial logging environment, you register your scribe, this one, and just use default settings here. Of course, in real app, you will never use default settings. You will do lots of other stuff. This piece of code is not very good. I tried to rewrite it to make it better, but it was quite difficult. So I tried to make it as simple as possible. But then you see that this std out is here, and here, and here it's a name, and you need all this stuff because if you are unable to create this log file, then you are not able to log anything. So the order is very important here, because after that, does everybody see here that we are using IO in let? So what does it mean? So we're defining action as a pure value. So we will pass it somewhere after that. So we're not executing it here. We just define it to pass it as an argument to another function. And another function is bracket. Bracket from control exception, so pretty standard bracket. So what we're doing here, so we want to initialize logging with this action. Then in the end, we will close all scribes with this action. And this is our actual application here. So the last argument of bracket. So we have to control all exceptions. And that's why we have to do make handle scribe before that. Because if creating log is failed, then we're just unable to do actual logging. So that's why we have to create it first, and then initialize all this stuff, and then do this application, and then in the end we will close everything. So that's it. Yeah, and let's look at this application. So another idea here in this library is a context. Context is some information which accompanies logging message. So context is something like this. If you open connection to some server and you do something with some server, this connection is a part of a context. So you want to know whom are you talking with at this moment. So this library is very good at doing things. So with context, so you just provide context, and if you have some more contextual information, you can add it. So it will be added into every logging instruction. And that means that you will have all information when you analyze your log. Not just a message, but also this object with this information. Okay, this is our initial context, and it will be just unit type, and all this context information will be transferred into JSON actually in the end. So it will be empty JSON object actually. So everything will be logged as JSON objects here. Initial namespace, it's a namespace for our application, and we'll use periods to make hierarchy of components. And then runner for this computation, and this my app is actually my app here. So all this stuff is configuring, and it's the simplest possible configuring. So well, it's industry, so you have to do things like that. By the way, I don't know a lot of things about industry. I never work in industry. Just my thoughts about industry. So I'm sorry if I'm just saying something wrong about that. But I think it's something like that there. Maybe much worse than this. It's like textbook industry. But logging is an easy thing here. So, and you can actually see that it's almost the same as in monologger library. So just, it uses template Haskell here for doing logging. But then we can do something different. So let's try. I will show you this sum action and another action. So what we are usually doing in application. So we may change some namespace. We may change context. We may add something to context if we are going deeper into our application. So that's what I was trying to show here. So this sum action adds namespace. So now we know that we are working within this action. Then we add some context. This function will add a part of JSON object with the name some context and the value true. Well, it will be somehow transformed into JSON using ASON library, which is quite traditional for Haskell. And it is also described in Get Programming's book by Wills, so it's another good thing in that book. So I think it's the only book on Haskell which even mentioned this library. It is transformed into JSON object, and this is the body of our action. So again, very simple logging stuff. So we are somewhere inside our application, so we have some context here, contextual information, we have some namespace, and of course we can go deeper and deeper, and it's no problem, it's all like that. As for another action, here you can see switching off this logging information. Again, you have all those logging instructions, but then you just say no logging, and then nothing in that action will be actually logged. So switching off completely, or you can put it this script no logging like in the very beginning, and then you will switch off your logging for the whole application just in a second.
Does this library also work on any mono stack?
Yeah. So it's in that sense it's pretty same. So you can use it in any monad stack. So it's just the same thing. Mm-hmm. Just layer for monad transformer stack. That's it. So it's pretty standard for things like that. And I think that this MTL style is the main style for writing industrial applications in Haskell. So there are many others, but they are not that popular, and this MTL is pretty standard. All right, this is an example, so what we can get from running that application. One problem with Katib library is that it has not very good documentation. So they have examples there, and I tried to run them, and they didn't work, and I had to rewrite them for an hour. So it took an hour to write this simple example. Well, my problem was to make it simple, so I just tried to simplify things, but then there were many problems. Or maybe half an hour, or maybe an hour. So, but well, you manage to configure it correctly, then that's fine. It all works. And the actually good thing is that there are, so that this library is able to give you clear instructions what to do. So this is a workflow for that library, and this is something which you do almost all the time. So as we did in our simple example, we just initialize environment for logging, and then we add as many scribes as we like, so different external servers, files, input, output, or error, whatever you want. Then you can build transformer stacks, or you can just have your own monad and implement special instances for working with this logging library, so just a standard MTL style programming. Then you define some so-called log items. It's almost the same thing as a context, actually. So log item is something which will be translated into JSON objects, and you are logging them. So you can log empty messages, but you can log a lot of JSON objects, and all of them will be concatenated, and in the end you will get all the information in your log. And this idea, when you're using structured logs, it can be used for logging into databases, for example. So you don't need messages there. You just want to log records into database. So you just have a table, and then you create rows for that table, and you just insert them, and that's it. So that can be a scribe. Then we log things with the instruction that we were talking about already. And then you can also define your own scribe. And the good thing about this library is that defining scribe is an easy task. So if you know your destination, then it's easy to write scribe for it. And that's why right now on Hackage we have these 4 libraries with actual backends. First 2 are quite mature, so they're used in industry, and they say that there were millions and millions of log crackers that were recorded using Elasticsearch, for example. And 2 last libraries, they're not, well, they're just very new, but you can use them. So Rollbar, as far as I know, is another recording logger service, cloud service. And the last one is about logging into JSON objects. So the whole log information is written into JSON file, and then you can analyze it using some other tools for JSON files. But these 2, they just, I think, they have several lines of code. They are very simple. You can look at them, and you will, well, but they work, so you can use them. And I think, yeah. All right, and now we are moving to the last world, which is the most interesting here. And in fact, I'm actually finishing. And I will show you one library which is very, very new, which is only 3 months old. And it is very interesting. So, and you can see that the author of this library is just a bunch of people. And if you can see that, all of them, they're Russian names. So it's a small team with the name Kavainik, and it's Russian guys based in Singapore, actually, and another guy who worked for Tweak.io. It's a consultancy company in Haskell. So they created this library, and they say that they are very serious. And we'll see that it's kind of scary library. And you can see that from this phrase. And it's actually half of the actual title of the library. And it's started in September, and it's now we have 3rd release. It's pretty new. Not too much downloads, but I hope that it will become popular in the end. So that's the actual name of that library. And it's the name of a blog post, which is very good. And I think that you should look at that library, and you should look at that blog post. And here, especially for you, I've created a short link, just not to remember all that line. Just go to Vitaly and co-log. And I will show you just several pieces of that library to give you an understanding how interesting is it. So everything starts with the simplest idea, with the simplest concept of a logging. Again, logging is a function, but now it's the simplest possible function. So what is a logging function? It takes a message and it works in some mode. That's it. So that's a logging function. Message and some mode. So that's it. It's a new type. So this is a function which is wrapped with a new type. So it's basically a function. Of the simplest logging action here, it just send an output. So put string line is a logging function, and it is able to log strings, and it works in IO monad. So it's just a logging function, the simplest possible. So now, if you want to write something into a log, your first goal is to acquire logging function. And this is something which is not necessarily which has not been done with logging library, by the way. So you can create your own environment with reader, for example, reader monad, and just take logging function from that. Or you can pass this logging function explicitly to every function, because it's not very convenient, but if you have free function, then that's fine. So they give some solution for acquiring that function, but it's pretty standard. So they're just using environment with the reader, and that's it. But just think about it. Getting this function is not a problem for logging library. It's something else. It's another task. So you don't have to think about that when you write logging library. And remember all those libraries before, which I was talking about, they were giving you ways to acquire that function. So this is something about composability and all that core stuff. So we just try to decompose as much as we can here. All right. So composition. So we have some logging action here. One is just printing to standard output, and another is printing to standard error. And here you can see a composition. It's just regular semi-group operation. So if you want to write logs into two handlers, into two destinations, you just build a composition using semi-group. So, and of course it's a monoid, because monoid is, if you need empty, then it's just logging to nowhere. So that's it. So we need math here. Well, as always in Haskell, almost everything is a monoid, as we know. So logging actions, they are monoids for sure. Another very nice piece of that library is that they use contravariants there. And this may look scary if you don't know what is it, contravariant functors and stuff like that. But actually it's very simple. So if you look at this type annotation, and you can think about it in this way, FB means that you are able to log values of type B. Like here, log action MB. So you have this function for writing out values of B. And if you have them, and you have this function for transforming A to B, then you can log values of type A. Well, you just take that value of type A, transform it into B, and then use logging for B. So logging is a good example of contravariance here. And once we have contravariance, we can apply all other stuff which was created for contravariant functors. For example, we can divide, like here, and this is what we are doing here. If we have some type, and we are able to split it into two parts, and we can log that parts independently, then we can log original one. So this is just type class divisible, which comes from contravariant package, and it's exactly what we have for logging. So you have some complex data structure, you split it into pieces, and then you log those pieces independently. And you may write some parts of it into destination, other parts into another destination, and that's it. So next type class here is decidable, which allows you to choose which part of the data structure to log. So you can use this function for choosing, and then you can log right part, you can log, which one is this? Left, yeah, this is left part or right part, you can log them, and then you just choose, and then you're able to log that part that you actually need here. So you can log very sophisticated data structure by analyzing them, by splitting them into parts, or by choosing something like here. They are doing even more funny stuff with all these things. And in fact, so just I'll show that again. So if you look there, you will see common examples and many other core words in that blog post. It's really very good. And it's quite simple, so everybody can understand that. So there are other approaches which are sometimes close to this one, but they are not that fun. So logging effect is another good library. Ollie Charles wrote it. It's 2 years old, and I think he was first in doing compositions, compositional logging, when you want to compose parts of your messages and you want to log them independently. There is some stuff for that in that library. Another approach is using extensible effects. So this is something which is orthogonal to MTL style. So they have logging too, they have effects for logging. So you see the names are close, but actually they're doing absolutely different stuff. So this is for MTL style, and this is for extensible effects. But they are quite good, they are quite sophisticated, so they are also interesting. So if you look at them, you will see a lot of interesting things. So in the end, I want to give you some guidelines, although they're not the guidelines actually. So they're just simple advices when you want to use something. So I think Monad Logger is the best way to go if you log something into files. That's fine. So Katip is good when you need to integrate some new backends. If you have something self-made cloud servers for logging, then Katip is easier to implement that integration. HS Logger is also good. It just too old, and that's why it's good. Everybody, you will find every answer for your problem on Stack Overflow immediately, so it's very convenient. And of course, these new libraries, they are. I think you're not supposed to use them in industry. Although their authors, they say that they will try in a month or so. So I will ask them about that. So I hope that they will be successful in that. All right, and that's what I wanted to talk about. And if you have any questions, please ask.
In the last library, is there any support for login time or source or any extra piece of information besides string?
It is possible to log, you mean colog library?
Yeah.
It's definitely possible to log time information. I'm not sure about location. I think that they don't have that yet. Maybe they have. They're so quick in changing things. So, but I don't remember that support there. So it's yeah, there are pieces of functionality that they don't have right now, but they are very active in developing that library. So their goal is actually to prove that it is possible to use all this fancy stuff with common ads in for real. So they're trying to prove that. So they'll do everything. Other questions, please? Yep.
Most of the examples you showed were just logging strings. What approach would you take if you wanted to log something bigger than a string, like a JSON object?
You mean in which library?
Put some, no, in any of the libraries, I suppose. But
So
like, Tip put some context on it, but I actually want to log JSON and not just strings.
So in Colog, for example, they are very good at that too. So you just log whatever you like. But anyway, when you log something, it's the destination which actually should know about this format. So if your destination is able to take this, then it's possible to give that to the destination, to put it there. So if you have a backend for database, you will have structured login, so you will give them actually rows of your tables. So if you're writing files, then you can use JSON, of course.
I just want I want a clean API when I'm writing the actual logging line, that it's not a string.
So definitely for Colog, it can be anything. You can just, but anyway, if you put it into standard output, then you have to provide some type class for transforming into strings. But it can be done very easily there. Yeah. But it's but in Katib they can do that. But yeah, they convert everything into JSON, and they can actually save that into. I showed that the last scribe was just for writing into JSON files, so it will give you JSON log in the end. So every context will be there, and every message will look like a JSON object. Yep.
The Haskell compiler likes to move things around. How do you ensure that if a crash happens, it happens after the logging instead of before?
When we are doing logging, we are mostly doing that in the IR. And when you are working with IR, well, it may be laziness issues, of course, but then it depends on how you do your exception handling. So if you are doing exception handling, then you have to evaluate fully everything. And then it's upon you to provide bracket or provide some exception handling things which will get that error and log that properly. So it's not a problem for Haskell. So we know how to. So if you have error, then you have some error handler, and then that handler will work after your error, and in that handler you will do your logging. So that's what they do, and it should work pretty well. So it doesn't have any problems with changing order of execution. If I get your question completely rightly. Mm-hmm. Other questions, please?
I've seen you mentioned the template Haskell, so I'm just wondering that is there a common practice to use Oxford brisket to log as a format to log out the information, just like yes or.
I never saw something like that. So, just, yep.
Hey, two questions. So the first one is, so last month at UFLA there was a very nice talk about logging actually in Node.js, but one of the things that they did was they measured the performance of the logging, and they found that they spend some absurd amount of time just converting things to string. on the main thread. And one of the ways that they like sped things up was by doing the two-string conversion often in a separate thread. Do you know if any of the Haskell libraries are doing like, you know, sparking off a new capability to do the two-string conversion off the main thread, or if it's all kind of synchronous?
Well, I think everything like that depends on the actual implementation, and for Katib, I know for sure that they are doing things in many threads, in any thread you have actually. So if you do logging in this thread, then it will convert everything in the same thread. But then you can do logging from different components, from different threads, and then they will use all that stuff. So I also know that for Katib they did a lot of performance checking, and they say that they are the best in class for that. So they're doing, especially when they're doing this cloud service thing. So I never checked that by myself, but I think that, yeah, or maybe there is so it's definitely not a problem for a single threaded conversion into strings. That's definitely not a problem. And second question?
Right, so my second question, so all of these libraries, they're all sort of push style, right? They're all running some monadic action interspersed with your own, you know, computation.
Right.
Are there any logging libraries that are more pool style, the way, since Haskell is lazy, so that a logging happens as a side effect of evaluating some pure value, or you know, the way that like debug.trace works, for example, where you attach this thing to a pure value, and then when the value is demanded, the trace happens.
Well, I showed example with write logging for monad logger. It's not like debug trace, but it's pure computation with logging, and but I don't think that it's a good idea to use things like debug trace in those programs. So as far as I know, they try to use normal Haskell without all that unsafe performer war things. Of course, I don't think that they really need that. So but you mean that? So you want to have pure computation and do logging impurely?
Yeah.
I don't think.
I think this is reasonable because logging is as you said at the beginning, it's a cross-cutting concern. So it's
right.
Something that I necessarily want to convert all of my code to monadic style just because I'm doing logging.
Right. Well, yeah. I don't think that. I don't know about any library which, well, you can use unsafe perform by yourself, right, and you can put it whenever you like in a pure chord and just put any IO computation for logging. So,
right,
but that's up to you. That's not the library's fault.
But you want to be disciplined about it, so you want.
I don't. I never let my students do things like that. Although they try.
Because you can get stuff logging twice or not at all because of that.
Right, so
yeah,
that's why
right.
I want the library's help, is to only log it the first
Oh,
values and then
the library can do that.
yeah, because it's execution, it's a compiler, it's.
If it thinks it's pure code, it can duplicate it. It can common subject version.
I mean, not if
I'm
it's
not sure about.
No, you're talking about direct support.
like modifying DHC, yeah.
Okay. Well.
I'm not sure about the CPU, but I'm not sure why not CPU can do some prediction and then say that after this IO part we can try to do some calculation, and if the branch catches, and then we can just throw out this computation result. I'm not sure. I'm just guessing.
Yeah, so I think it's not a good idea. It's just hacking, and it's not what we normally do in Haskell. Maybe in industry they do. Well, yeah, that's
How do
right.
we catch some
Yeah.
computation result and giving them back after I/O?
But I think that for that you have to modify, well, just it's awful stuff. It's like evaluating those core inside it. It's just, well, that's scary.
But then you're logging at the, in the semantics of the language, which is,
Yeah, but you write programs which you write unpure programs and say that they are pure. I think that's a crime.
But if after I/O the context is context free or context free from the I/O, then or context free
Well,
from
then
the
then
level.
then you can use other monads for logging. Oh, you use writer.
What?
You can use writer all the time.
Oh yes,
Of course,
yes.
it's
Right.
it's not very convenient. Okay, other questions? We have 7 minutes till the end.
I think I shot myself in the foot when debugging with debug.trace and STM. It's like, why is this happening all this time? Oh, because the transaction is being retried.
Yeah. All right. So, thank you very much again. I was happy to talk about this. Thank you.